All right, so number one, we're going to convert this radian measure to degrees. So radian measure to degrees is a pretty simple process that hopefully you watched the video on. We just multiply the radian measure times 180 divided by pi, which is essentially equivalent to 1. The pi's cancel out diagonally. I can reduce 180 over 10 and then just multiply the tops. So 9 times 18 is, I believe, 162. And we do have that option. And here we're going the opposite direction. They give us a degree, and we're going to convert that to radians. So we'll take 135. You can put it over 1 if you like. And this time we're going to multiply it by pi over 180. You could reduce these two right here diagonally at this point. I'm going to go ahead and multiply across the top and just reduce at the end. I'm going to reduce both of these by 5 because I know 5 goes into both of these numbers. So that's going to be 27. And 180 divided by 5 is 36. But then I see both of those numbers are both divisible by 9. So I'm going to reduce both of these by 9, and that's going to give me 3 pi over 4 radians. Make sure you're showing work, not necessarily on this problem, since it's multiple choice and you may not have that option. But these problems below that give you notebook paper, you are required to show your setups for these problems. So this next problem, it gives you a central angle, ABC. Remember, it's important to know your terminology here. This is a poorly drawn central angle here. But this would be central angle A, B being the center. That's supposed to be the center of the circle. And they tell us the measure of that angle is 40 degrees. It wants to know the measure of the arc that is subtended by the central angle. So essentially the arc is the part of the circle from point A to point C. The arc is always measured in radians. So essentially this is another way to say convert 40 degrees to radians. We'll take 40, multiply it by pi over 180. Both of these are both divisible by 10. So that's 4 pi over 18. And then both of those are divisible by 2. So that's 2 pi over 9 radians. That's how long the arc of the circle is. All right, so this next question, we're going to change gears a little bit. It wants the reference angle for 11 pi over 6. So we should know our 4 quadrants. So we start at 0 pi, then we go to pi over 2. Over here, this is pi, 3 pi over 2, and 2 pi. Or in other words, this is 90 degrees, 180, 270, 0, or 360 degrees. There is the option of converting this to degrees and then back to radians. But the preferred method is to understand 11 pi over 6. Which quadrant is 11 pi over 6? That's equivalent to 1 and 5 pi over 6. So that's 1 and 5/6 is somewhere in this quadrant, quadrant number 4. So we want to identify exactly where it is so we can identify the reference angle. Even if we don't know exactly where it is in that quadrant yet, if we haven't gotten to that point, we know the reference angle. So let's say this is 11 pi over 6 right here. Let me erase that circle. The reference angle is the rest of the angle's distance, if you will, to the x-axis. So this is our reference angle right here. So to find that distance in red, we're just going to take the full 2 pi and subtract the angle we started with, which is 11 pi over 6. In other words, just what is 2 minus 11/6? So we can get a common denominator. And that's going to be 1 pi over 6 is our answer. It's important to know reference angles cannot be negative. Reference angles are always positive. So you could have ruled out choices C and D from the get-go there anyway. Let's do an angle measure. So again, reference angles are always positive, but all these numbers are already positive. So that's not going to affect anything. So when we sketch negative 230, we're going to go clockwise. So that's 90, negative 90. That's negative 180. There's negative 230 altogether. But if we know this piece is 90, this piece is 90, this piece is 50. By definition, the reference angle is the shortest distance to the x-axis. So here it is. The terminal side of that angle's shortest distance to the x-axis is 50 degrees. So here they want us to sketch an angle that is coterminal to the angle below. So it might be helpful to first sketch the angle they give us to see exactly where it is. Except we know that coterminal means two angles that start at the positive x-axis and they end in the same place, but they come from other directions. In other words, we know that 359 and negative 1 degree, those angles are coterminal. They add up to 360. The absolute value of those two numbers adds up to 360, but they come from different directions. So that means the angle that's coterminal to 7 pi over 6, we'll call it x. The absolute value of that angle has to add together to give us 360 degrees, or in this case, 2 pi. So to solve this, we would subtract 7 pi over 6 from both sides. So real quickly, 2 minus 7 over 6 would be the same thing as 5 pi over 6. So the absolute value of the angle has to be 5 pi over 6, but we know since this angle is positive, the angle that's coterminal to it has to be coming from the other direction, so it has to be negative. So essentially we're wanting to sketch the angle negative 5 pi over 6. So we're going to be going clockwise since it's a negative angle. We know this is 0. We know this is pi over 2. We know this is 1 pi. If it's helpful, again, you can convert that to degrees if you like. But we know negative 5 pi over 6 is going to be somewhere in this quadrant. because it's in between 1/2 and 1. So you can see I did the work there. I went ahead and converted it to get the exact angle measure. So I'm going to draw the initial side. It's kind of hard to do here because it's a thick black line, but this is the initial side of the angle you need to sketch. If I can use a thicker tool here, it's a little better. And we're going to go this direction. So that's negative pi over 2, or negative 90. There you go, 60 more degrees. We're just estimating here. Doesn't have to be perfect. Main thing is I want to see it in the correct quadrant on your paper. All right, and then finally draw an angle that's coterminal to 250. So that means the absolute value of the coterminal angle, we'll call it x, has to add to 250 together to give us 360. We subtract 250 from both sides, we get 110. But we know we need the angle to be negative. Again, how do we know that? The angle they gave us was positive, so that means it's going counterclockwise. So the other angle has to be coming the other direction, it has to be going clockwise. So negative 110, I'll do this in red. Again, draw the initial side. There's negative 90, and then we need an extra 20 degrees. Should be about right there. So that's the coterminal angle to the provided angle. Question 15. Given the following angle, which quadrant will the terminal side lie in? Remember, terminal means ending side. So if we quickly sketch this angle, you don't necessarily have to. Here's the initial side, the positive x-axis. 315 is positive, so we're going counterclockwise. That's 90. That's 180. That's 270. Which means we need to go 45 more degrees. That's 315. The question wants to know what quadrant will the terminal side, this is the terminal side. Terminal side ends in quadrant 4. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Then finally, same question, except this time we're starting with negative 315. So we're going to be going clockwise since it's a negative angle. So there's 90, negative 180, negative 270, negative 315. It wants to know what quadrant is the terminal side in. Here's our terminal side right here. This is quadrant number 1.